Today we're telling a story about a crisis happening in a kitchen. But this isn't about some fancy restaurant. Nope, this is about the tiny, microscopic kitchens inside your cells. And believe me, understanding what's going on in there, well, it changes how you see diabetes completely.
So let's just jump right in. I want you to picture something for me. What if your body was a huge, bustling restaurant? I mean, think about it. Kitchens, waiters, orders flying around everywhere. It sounds simple, but trust me, this one idea is going to unlock our entire understanding of one of the biggest health challenges in the world today.
And why does this story matter so much? Because for a huge number of people, that restaurant is in deep, deep trouble. And when I say huge, I mean staggering. According to the International Diabetes Federation, 537 million people around the world are living with diabetes. So yeah, figuring out what's going wrong in the kitchen, it's never been more important.
Okay, so before we get into the crisis, let's start with what's supposed to happen. When everything is running like a well-oiled machine. Let's take a quick tour of a perfectly well-run kitchen.
Every time you eat a meal, boom, the food orders start coming in. In our bodies, that order is glucose. It's basically the sugar from your food, and it gets right into your bloodstream. Think of it as the raw ingredient, the fuel that powers literally everything you do.
Now, you can't just have all those orders piling up, right? Someone's got to deliver them. That's where our waiter comes in. And that waiter is insulin. It's the super important hormone your pancreas makes, and its whole job is to grab that glucose order from your blood and rush it over to the kitchen door.
And where is it going? Straight to the kitchens. And what are the kitchens? They're your cells. We're talking muscle cells, liver cells, fat cells. They're all waiting for that delivery. They're designed to take that glucose order from insulin and, right away, start cooking, turning that fuel into the energy you need to live your life.
So when it's all working, the process is just beautiful. It's simple and incredibly efficient. Let's run through it one more time. You eat, glucose hits the blood. Your pancreas sends out the waiter, insulin. Insulin knocks on the cell's door, the cell opens right up, takes the glucose, bam! A perfect delivery, every single time.
But what happens when the orders just don't stop? What if the kitchen gets slammed, non-stop, hour after hour, day in and day out? Well, that's where our story takes a turn. This is where the trouble begins.
And this right here really gets to the heart of the problem. A healthy cell, it hears that polite little knock from insulin and no problem, opens the door. But a cell that's been overwhelmed, it starts to tune it out. The knock just becomes background noise. So to be heard, the waiter has to start shouting.
Now, this whole tuning out thing, that's what scientists call insulin resistance. And here's the formal definition, which basically says it's an impaired biologic response. In plain English, the signal is being sent loud and clear, but the message just isn't getting through anymore.
So if the kitchens are going deaf, what does the restaurant manager, your pancreas, do? It does what any manager would. It tells the waiters to yell louder. The pancreas goes into overdrive, pumping out more and more and more insulin, trying to force those cells to respond. This leads to constantly high levels of insulin in the blood, a condition called hyperinsulinemia.
Look, this system can't go on forever. Any system under that much constant stress is bound to break. And this is the breaking point. This is when we enter a full-blown kitchen in crisis, dealing with critical overload and dangerous overflow.
Just imagine, your pancreas has been working double shifts with no breaks, maybe for years. Those specialized little beta cells that make all the insulin, they get completely exhausted, burnt out. They simply can't keep up with the relentless demand anymore. Production slows way down, and the body's whole ability to manage that flood of glucose orders, it starts to collapse.
So what happens to all those undelivered food orders? The body scrambles to store them, but the main pantry, our fat tissue, is already full to bursting. So the body starts stuffing that excess energy into places it absolutely does not belong. This is called ectopic fat. It builds up in your liver, in your muscles, basically gumming up the machinery and making those kitchens even more deaf to insulin signal. It's a terrible, vicious cycle.
Okay, but hang on. Here's where the story gets really, really interesting. What if this isn't a failure at all? What if it's a defense mechanism? This quote suggests that insulin resistance is actually a cell-protecting mechanism. Your cells aren't just being stubborn, they're trying to save themselves from the toxic damage of too much energy. They are literally locking the doors to survive.
In realizing that, well, it changes everything, doesn't it? The problem isn't a broken waiter or a faulty kitchen door. The problem is just too many orders flooding in. So the solution isn't to fix the door, it's to restore order. It is time to renovate the kitchen.
And when you see it that way, the goal becomes beautifully simple. We have to do two things. First, we have to reduce the number of orders coming in. That's the energy from our food. And second, we have to improve the kitchen's efficiency so it can handle the orders it does get. In other words, we need to restore the cell's sensitivity to insulin.
All right, so how do we actually do that? First thing, we change the menu. This means reducing the total number of orders, or calories, especially if weight loss is part of the plan. It also means balancing the plate with a good mix of protein and healthy fats. And when it comes to carbs, the key is quality. We want to choose foods like vegetables and whole grains that don't cause a massive, sudden rush of orders.
Next up, we improve the kitchen's efficiency with a new training program, exercise. The goal is to aim for at least 150 minutes of moderate intensity activity every week. Why? Because physical activity literally makes your muscle cells much more sensitive to insulin. Both aerobic exercise like jogging and resistance training are incredibly effective at waking up those kitchens and getting them ready for business.
So in the end, when you look at the whole picture, insulin resistance isn't your body failing you. It's your body trying desperately to protect you from an overwhelming flood. It's sending a signal, a cry for help. The real question then becomes, your body's trying to protect itself. How are you going to help it?